let's find the double integral of x plus y dA, where over the region R, where R is to the left of the y-axis between the curves of radius 1 and 2 from the origin. So if I draw a picture of this, see on the left of the y-axis, so that's over here, and I need a radius of 1 and a radius of 2. So this is the region on the xy axis, and this is the surface above it on the z value. So what do I have here? I'm going to take a look at converting a few things. This looks like I should be easier in polar coordinates. So recall that x equals r cosine theta, and y equals r sine theta. So using this to substitute in, I can take a look at the integral and the angles. I'm going to start up here at pi over 2, then come down to 3 pi over 2 of, see, this is going to be r cosine theta plus r sine theta, r dr d theta, and I missed this one. I need to go from 1 to 2 in reference to r. Well, I would rewrite this as, see, pi over 2 to 3 pi over 2, 1 to 2 of cosine theta plus sine theta times r squared dr d theta. Now I'm going to integrate this obviously in two different pieces. So the first piece, I'm just going to work with this, and that's going to give me cosine of theta plus sine of theta times r cubed over 3 evaluated from 1 to 2, which is going to be cosine of theta plus sine of theta times 8/3 minus 1/3, so that's just going to be 7/3. So now I'm going to work with that second piece, and this will be 7/3 times the integral from pi over 2 to 3 pi over 2 cosine theta plus sine theta d theta, which is 7/3 times sine theta minus cosine theta evaluated from pi over 2 to 3 pi over 2. Now for both of these, cosine is 0, so I can pretty much simply ignore the cosine. When sine is 3 pi over 2, or when theta is 3 pi over 2, I get a negative 1. And when theta is pi over 2, sine is 1. So this is going to be 7/3 times a negative 1 minus a positive 1. So that's negative 14/3.